Good morning and once again welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamotho. And of course we continue to explain Pure Mathematics 3, and today we are glad we are going to the very last topic of this book, which is called Numerical Methods. And having introduced the topic in video 1, in video 2, in this topic, we are going to directly go to example 1. And we are told that in example 1, the diagram shows a sketch of y is equals to fx. And there is a sketch of y is equals to fx. And we have, this is 1, we have 1 here, x-axis, we have a 2 there, and we have a 3 there, and fx is equals to x cubed minus 4x squared plus 3x plus 1. It's a cubic function. And we are told that explain how the graph shows that fx has a root between 2 and 3. Explain how the graph shows the function has a root between 2 and 3. Of course, we have understood that any time a function has a root between two numbers, that function must be crossing the x-axis. In other words, it must be changing the sign within the limits. When x is equals to 2, of course, if you happen to substitute x being equals to 2, then you realize that y will be negative. You can see already y will be negative. If you happen to substitute when x is equals to 3, you can see that the function will be giving you a positive number. So probably we can just verify that f, the function of 2, is when we substitute x in the function, minus 4, 2 squared plus 3, 2 plus 1. And this is 8 minus 16, which is minus 8 plus 6 minus 2 plus 1 is negative 1. When x is equals to 2, y is equals to negative 1. This is going to be negative 1. When if you substitute x with 3, you're going to have 3 cubed minus 4, 3 squared plus 3, 3 plus 1. This is 27 minus 36. That is minus 9. Minus 9 plus 9, 0. 0 plus 1 is simply a 1. So you can already see that that is in line with 1y is equals to 1. So yes, we have shown that the graph crosses x-axis between 2 and 3. This means that the root of fx lies between 2 and 3. It changes the sign. So our ultimate answer to this one is the graph crosses x-axis. It crosses x-axis between x is equals to 2 and x is equals to 3. In other words, there is change in sign. Change in signs. Part B of the question show that fx has a root between x is equals to 1.4 and x is equals to 1.5. It has a root between x is equals to 1.4 and x is equals to 1.5. It's very hard to tell from this graph, but you can obviously see that there's another root between x is equals to 1 and x is equals to 2. But the question is asking us to prove that those limits have been squeezed. They have been shrunk. They have been shrunk so much, and we can prove that the root is between 1.4 and 1.5. Let's see. The only thing that we need to do is to simply substitute x with 1.4 and say f 1.4 is going to be 1.4 cubed minus 4 1.4 squared plus 3 1.4 plus 1. And if you apply the calculator correctly, you'll realize that the fx is 0.104. Of course, this is positive. When we have the function of 1.5, we do likewise, cubed minus 4, 1.5 squared plus 3, 1.5 plus 1, which is going to give you negative 0.125. This is, of course, negative. So the fact that there is a change of sign, the fact that there is the fact that there is a change of signs between x is equals to 1.4 and x is equals to 1.5 proves that the function has a root between 1.4 and 1.5. This is simply what we need to show and what we need to prove. Otherwise, again, visit my YouTube channel, Pearson and Excel International Maths, and of course, subscribe and share widely so that we can work together. All right.